Welcome back. This is section 1.10 line. So in this section, we're going to look at what the equation of a line looks like, the graph of the equation of a line, and then also what it means for lines to be parallel and perpendicular. All right, so to start out here, we have the slope of a line. So if we have 2 points, x1, y1, x2, y2, we can actually calculate the slope, which we use a lowercase m to denote slope. That's going to be y2 minus y1 divided by x2 minus x1. And another way you might have seen it before is what we call rise over run. So we're looking at how much do we rise, what's the vertical change, over the run, which will be the horizontal change. Now, if you look down at the bottom, we can see we have an example of what a positive slope would look like. So from left to right, that graph would be increasing. That means it has a positive slope. If we go from left to right and it goes down, then we have a negative slope. Horizontal lines will always have zero slope. And then if we have a vertical line, we could say that that slope is either undefined or it has no slope at all. All right, so example 1, we just want to find the slope of the line that passes through these 2 points. And so all we have to do here, use our formula that we just saw. So it's going to be m equals y2 minus y1 over x2 minus x1. So again, if we label our points up here, the 2 is going to be our x1 value, the 1 is going to be our y1 value, the 8 then would be our x2, and the 5 would be our y2. Right, so now we just substitute our values in there. So starting with y2, that's going to be 5 minus 1 over, and then x2 minus x1 is going to be 8 minus 2. And now we can subtract. 5 minus 1 should give us 4. 8 minus 2 is 6. And then we always want to look to see if we can simplify these fractions. 2 actually goes into both of those values, so we get 2 over 3, and that's going to be our slope. So again, just make sure y values always go on top. We're just subtracting the y's and then dividing by the difference of the x's. All right, now, an equation of a line that passes through the point x1, y1 and has a slope of m can be found using this equation here. This is what we call the point slope form for the equation of a line, because if you know a point and you know a slope, then we can plug into this formula, and that's going to give us the equation of our line. So notice y and x will actually stay y and x. The y1 and x1 become numerical values, and then our slope, same thing, that will be a number. All right, so we want to find an equation of the line that goes through the point 1, negative 3, and has a slope of negative 1/2. So we're going to use that formula that we just saw. So y minus y1 equals m times x minus x1. And so this time our point gives us our x1 and y1 values, and then our slope is going to be our m value. So now we just substitute. Again, the y value stays y, minus the y1 value, which is negative 3. And that's going to be equal to the slope, which is negative 1/2, times x minus our x1 value, which is just 1. Now, because we're subtracting a negative 3 there, that's going to turn into addition. So we get y plus 3 equals, and now we can actually distribute the negative 1/2 here. So that's going to give us negative 1/2 x. And then negative 1/2 times negative 1 becomes a positive 1/2. And then at that point, all we have to do, we can actually solve this for y now. We can subtract the 3 on both sides. So when we do that, we're subtracting 3 from positive 1/2. So we get y equals negative 1/2 x. And then this is going to give us negative 2.5 or negative 5/2. So however you want to write that is fine. Now, this form of the equation of a line is what we call slope-intercept form. It's a form that we're going to look at in just a minute. Okay, but just so you know, when you solve for y like this with a linear equation, this form that we just found is called slope-intercept. Okay. And the reason we call it that is that we have our slope, right? That's our m value right here. And then this value is actually going to be the b value, which is the y-intercept of our graph. Now it does ask us to sketch the line here, so I'm going to sketch a graph of this. Now we can base this off of just the original point and the slope, so I'm going to plot that original point 1, -3. So we go to the right 1, down 3, start your point right there. And then our slope is going to be -1/2, which means we're going to go down 1 and to the right 2. So down 1 to the right 2. It's going to give us a point right over here. And once you have 2 points, that's enough to graph a line. If you want to do another point just to be safe, you can do that. Okay, but from here, I'm going to sketch my line going through those 2 points. And so we get something that looks like this right here. Okay, and notice our graph is decreasing from left to right. Okay, and that goes back to that negative slope, -1/2. Okay, and it does have to pass through the point 1, -3 here. All right, now this time we want to find an equation of the line that goes through the points -1, 2, and 3, -4. Well, if you remember the previous example, they gave us a point and they gave us a slope. Well, this time they gave us 2 points instead. So what we're going to have to do first is calculate our slope. So I'm going to use my slope formula. In this case, I'm going to go with y2, that's -4, minus y1, which is 2. I'm going to divide that by x2, which is 3, minus x1, which is a -1. Now, if we subtract, -4 minus 2 should give us -6. 3 minus a -1 becomes addition, so that gives us 4. And now if we divide each of those numbers by 2, that's going to give us -3 over 2. So our slope is -3/2. Now that we have the slope, now we can use that slope along with one of our points, and we can actually write the equation of our line. So I'm going to let this be x1 and y1, and I'm going to use that point slope formula that we looked at previously. So this is going to be y minus 2 is equal to -3/2 times x minus -1. Now the first thing I see here is I've got subtraction of a negative. I'm going to go ahead and change that to addition. So this is y minus 2 equals -3/2 times x plus 1. Now we can distribute the -3/2. So that's going to give us y minus 2 equals -3/2 x. And then -3/2 times 1 is a -3/2. And then finally, we can add the 2 to both sides just to get y by itself. So now we have y equals -3/2 x, and then -3/2 plus 2 is going to give us a +1/2. So we get +1/2. Okay, so there's the equation of our line that goes through those 2 points. And again, the first thing you have to do is calculate your slope. Once we know the slope, we have a point, then we can use point slope. Now, the other thing to note here is it does not matter which point you use. If we had used the 3, -4 along with our slope of -3/2, and then we get this in the slope intercept form, you would get exactly the same equation. So it does not matter which point you use for your point slope formula. It's going to work out to the same equation either way. All right, so here is our slope intercept form. So notice we have y equals mx plus b. M still represents the slope, and then b, like I told you before, is going to be the y-intercept of your graph, meaning where the graph crosses the y-axis. All right, so we want to find the equation of a line that has a slope of 3 and a y-intercept of -2. Well, this time, all we have to do is use that formula we just saw, y equals mx plus b, because they give us the slope, there's our m value, they give us the y-intercept, there's our b value, and so if we just plug those in here, that's going to be y equals 3x, And then plus b is just going to be a -2 because the b value is a -2. So whenever they give you slope and y-intercept, it's pretty easy just to plug those into that slope-intercept form, and we don't have any other work to do there. Now the next one's asking us to find the slope and y-intercept. So the first thing we've got to do is get it in slope-intercept form, which means we need to get y by itself. Well, to do that, I need to move this -2x. So I'm going to add 2x to both sides of my equation. It's going to give us 3y equals, notice these are not like terms on the right-hand side, so that's just a 2x and a +1. Now at that point, to get y by itself, we need to divide by that 3. So I'm going to divide by 3. But that means I need to divide everything by 3. So everything on the right-hand side also gets divided by 3 now. So there's our y. This is going to give us 2/3 x plus 1/3. Now, once we have that, and now we're in slope-intercept form, now we can figure out the slope and the y-intercept. So our slope, m, is going to be 2/3, and our y-intercept, b, is going to be 1/3. And so then if you needed to sketch that, then you could just plot a point at 1/3 on the y-axis, and then use your slope up 2/3, and then you'd have another point, and we could draw our line through those 2 points. All right, now vertical and horizontal lines. So an equation of a vertical line through a point is going to be x equals whatever that x value is of your point. Okay, so in this case, x equals a. If we want a horizontal line through that same point, then it's going to be y equals whatever the y value is of that point. So here it's just y equals b. So anytime you have x equals some number, that's going to be a vertical line. Anytime you have y equals some number, that's going to be a horizontal line. All right, so we want to find an equation for the vertical line through the point 3, 5. So again, we know it's going to be x equals some value. So we can start with that, x equals, because it's a vertical line. And then we need to use the x value of the point that's given. In this case, that's just 3. So x equals 3 would be our equation for that vertical line. Okay, now it's asking us to graph the equation, x equals 3. So I'm going to sketch that. So here's my x-axis, y-axis. I'm going to go over to x equals 3. So 1, 2, 3 on the x-axis. And then we need a vertical line that goes through 3. So it's going to look like this right here. So there's the graph of that equation, x equals 3. And now the next one asks for the equation of a horizontal line that goes through 8, -2. Well, horizontal line is going to be y equals some number. And in this case, we need the y value from the point that's given, so that's going to be -2. So y equals -2 would be the equation of our horizontal line that goes through that point. And then we're asked to graph the equation. Okay, so in this case, we want to go down to -2 on the y-axis. And like we said before, this is going to be a horizontal line. So it's going to go through 2 on the y-axis. And so that right there would be the graph of the equation y equals -2. All right, now the general equation of a line. So the general form here is going to be ax plus by plus c equals 0, where a and b cannot both be 0. Okay, so they could be one of them 0, but not both at the same time. Okay, but in general, that's going to be the equation of a line. Now, conversely, every line is the graph of a linear equation. Okay, so anytime you see a line, it's going to be the graph of a linear equation. Now, this general form we don't use very often. The common forms are going to be our point slope and our slope intercept. Okay, so those are the two that you really need to be familiar with. Those are the two that you could actually use in WebAssign and also on test. All right, so we want to sketch the graph of this equation, 2x minus 3y minus 12 equals 0. So there's a few ways to do this. You could just create a table of values, plug them in, find some points, and actually plot them. Or we could take this general form now, we could get it into one of our more familiar forms, and then we could actually graph from there. So that's what I'm going to do. I'm going to try to get this into slope-intercept form so that then I can just use slope and intercept and then actually graph the equation. So to get it in slope-intercept form, remember, we need to get y by itself. So the first thing I'm going to do, I'm going to go ahead and add the 12 to both sides and get that over to the right. So now we have 2x minus 3y is equal to 12. Again, we're still trying to get y by itself, so I need to move that 2x. So I'm going to subtract the 2x on both sides. That leaves us with a negative 3y equals, and now we cannot combine these, so this is a negative 2x and a positive 12. And then finally, we need to divide to get y by itself, so I'm going to divide by negative 3. And again, that means I need to divide every term on the right by negative 3. So negative 3 here, negative 3 here. There's our y value. Negative 2 divided by negative 3 is going to become a positive 2/3 x. And then 12 divided by negative 3 is a negative 4, so just minus 4. Okay, so there's our slope-intercept form. So now we want to sketch the graph from that slope-intercept form. So I'll draw my axes here. Y-intercept is negative 4, so that's where I'm going to start. So I'm going to go down 4 on the y-axis. This time our slope is 2/3, so that means we're going to rise 2 and then run 3. So I'm going to go up 2 units. I'm going to go to the right 3 units. And then I'm going to put another point right there. And once I have those 2 points, again, that's enough. If you want to do one more point, that's perfectly fine. But I'm going to go ahead and draw my line through these 2 points. And so we get a line that looks something like this right here. Now, keep in mind, if you're using a program like Desmos, Desmos will let you put in equations without actually solving for y first. So you could actually put in that original equation. If you're using a graphing calculator, however, all you have access to is a y equals. So then you would need to get this into slope-intercept form to actually put in the 2/3 x minus 4. And then you could see that it should give you an equation that looks like that. All right, parallel lines. So 2 non-vertical lines are parallel if and only if they have the same slope. Okay, and so when you see this if and only if, that means that we can read this in either direction. So 2 lines are parallel if they have the same slope, and if they have the same slope, 2 lines are going to be parallel. Okay, so it doesn't matter which order I read that in, it's always going to be true no matter what. All right, so we want to find an equation of a line through the point 5, 2, parallel to the line 4x plus 6y plus 5 equals 0. Well, we just said that parallel lines have the same slope. So if I can find the slope of this line, then I'll know the slope of my parallel line also. Well, to find the slope of this line, I'm actually going to have to get it into slope-intercept form. So I'm going to go through those same steps we did on the last example. I'm going to subtract 5 first. So now we have 4x plus 6y equals negative 5. Now I'm going to move the 4x over. So I'm going to subtract 4x from both sides. Now we have 6y equals, again, we can't combine these, so we have a negative 4x and a negative 5. And then we need to divide by the 6, which means I have to divide every single term by 6. So we get y equals, now negative 4 over 6 we can actually simplify because 2 goes into both of those values, so we get negative 2/3 x minus 5 over 6. Now, in this case, all we care about with this line is what its slope is, because we know the line that's parallel has to have the same slope. Well, my slope of this line is going to be negative 2 thirds. Now that we have that, and we have a point that's given, now I can use my point slope formula and I can find the equation of the line that we want. So this is going to be y minus the y value from our point, which is 2, equals our slope. And since it's parallel, we're going to use the same slope, times x minus our x value from our point, which is 5. Now, technically, it just says find an equation. That's an equation, so we could stop there. If you want to get it into slope-intercept form, if you're trying to graph it in your calculator or anything like that, then we would need to distribute first. So we'd have y minus 2 equals negative 2/3 x. Negative 2/3 times negative 5, that's going to become positive 10/3. And then our last step, we just need to add the 2 to both sides. Now we have y equals negative 2/3 x. And now 10/3 plus 2, if you get a common denominator, that's going to be 6/3. So we're going to end up with 16/3 once we add those together. And again, for purposes of a test, if it doesn't specify that it has to be in slope-intercept form, that original form is perfectly fine where you left it in point-slope form. But if it does say that it has to be in slope-intercept, just make sure that you solve for y there. All right, now perpendicular lines. So two lines with slopes m1 and m2 are perpendicular if and only if the product of their slopes is equal to -1. In other words, m2 is going to be equal to the opposite, or -1/m1. Perpendicular line slopes are opposite reciprocals of each other, meaning that we change the sign and we flip them. Okay, so that's what we have to do if we're looking for the slope of a perpendicular line. Now, horizontal lines have a slope of 0, vertical lines have an undefined slope, and those will always be perpendicular to each other also. So a horizontal line is always going to be perpendicular to a vertical line. All right, so we want to show here that these points form a right triangle. Now, first thing I'm going to do is I'm actually going to plot these points. I'm going to use Desmos to do it, though, just because some of these values are a little large, and I don't want to draw a coordinate plane with such large values. So I'm going to switch over there. And so now I'm going to plot the points that are given. So we had 3, 3. We had 8, 17. And we had 11, 5. Now, a lot of those, or 2 of those points are off screen, so I'm going to have to adjust my window here. So I go to my graph settings. I know my largest x value here is 11, so I'm just going to make this 15 so that I can see that point. And then our largest y value is 17, so I'll just make that 20 just to make sure we can see that point. And so now we can see all 3 of our points here on screen. And so what we're trying to show is that this is a right triangle. Well, that means that we need to have 2 of our line segments that are going to be perpendicular to one another to form that right angle. Well, if we look, that's not going to happen at the point 3, 3. Okay, so you can kind of see from that, the perpendicular is either going to happen between there and the red point, and then the black point and the red point, or it could be between the red and black or the blue and black. And I think it's going to be from 3, 3 to 8, 17, and then 11, 5 to 8, 17. That's where the right angle is going to form. So that's what I'm going to do, is calculate my slopes now between pairs of points to figure out if we have a pair of lines that are perpendicular to each other. Okay, so again, I'm going to pair together the 3, 3 and the 8, 17. I'm going to find that slope, and then I'm going to find the slope between 11, 5 and 8, 17. Okay. All right, so if we look for our slope between the first pair of points here, we're going to do 17 minus 3 over 8 minus 3. 17 minus 3 is going to give us 14. 8 minus 3 is going to give us 5. All right, so now we need to do the same thing with the other pair of points over here. So we're going to have m equals, I'm going to do 17 minus 5 over, and then 8 minus 11. And if I do that, 17 minus 5 is actually going to be 12. 8 minus 11 is going to be negative 3. Now, when I simplify that, that's actually going to give us a negative 4. Notice that that is not the opposite reciprocal of the other pair. Okay, so based off what I saw on the graph, because the graph was a little stretched, that's not the points we actually want to look for. Okay, so now I'm going to go back and I'm going to say, well, let's test a different line segment then and see if it's perpendicular instead. Okay, so the pair that I haven't tested yet, because we looked at, this is point Q and point R. We also looked at P and Q. So our other pairing that could work would be P and R. Okay, so that's what I'm going to focus on next. So I'm going to look at the slope between point P and point R, which is 11, 5. So now I'm going to calculate that slope instead. So this is going to give us 5 minus 3 over, and then we're going to have 11 minus 3. Well, 5 minus 3 is going to be 2. 11 minus 3 is going to be 8. And if we simplify that, 2 goes into both of those values, so we get 1 over 4. So now if we look, this value here, negative 4, and this value right here, 1/4, those are actually opposite reciprocals of each other. One is negative, one is positive, and 4 is the reciprocal of 1/4. And so in this case, because we end up with pairs of points that give us perpendicular lines, we can say that there is a right angle there, and so we do indeed have a right triangle. So again, think about your pairs of points, right? Find the slope between each pair of points, and as long as 2 of those slopes are opposite reciprocals of each other, then we know we have a right angle, and so therefore this is going to be a right triangle. All right, so now we want to find an equation of the line perpendicular to the line 4x plus 6y plus 5 equals 0 that passes through the origin. Well, to find the equation of a perpendicular line, first thing we need to do is find the slope. So again, I'm going to get this equation in slope-intercept form so that I have my slope. So I'm going to subtract 5. Then we're going to have 4x plus 6y equals negative 5. I need to move my x term to the other side, so I'm going to subtract 4x. It's going to give us 6y equals, again, can't combine those, negative 4x and a minus 5. Divide by the 6, every single term. So we get y equals, simplifying this now gives us negative 2/3 x minus 5 over 6. Now, the slope of that line is negative 2/3. So once we get into slope-intercept form, now we have our slope. Remember this time, though, we're trying to find the equation of a line that's perpendicular to that line, which means the slope of the line we care about is going to be the opposite reciprocal. Well, that means it needs to be positive, and the reciprocal of 2/3 is going to be 3/2. So our slope is going to be a positive 3/2. Now, once we have a slope, the other thing we need is a point. Well, they don't give us an ordered pair this time, but they do tell us that we want this to go through the origin. Well, the origin is the point 0, 0. So now we do have a point at 0, 0. So I have my slope, I have my point. Now we can go to point slope. So it's going to be y minus 0 equals 3/2 times x minus 0. At that point, y minus 0 is just y. Distributing here, this is just going to give us 3/2 x, because 3/2 times 0 would just give us 0 also. And so there's the equation of our line that's perpendicular to the given line, and it has to pass through the origin. All right, and then an application problem. So a swimming pool here is being filled with a hose. The water depth y in feet in the pool t hours after the hose is turned on is given by this formula, y equals 1.5t plus 2. So we want to find the slope and y-intercept and then interpret what those would mean in the context of this problem. Okay, so just looking at this, it's already in slope-intercept form. So our slope is going to be 1.5. Our y-intercept is going to be positive 2. So now we just need to discuss what those actually represent. Well, in terms of the problem here, we're saying that we are pumping water into this pool, and T represents the number of hours. Well, the 1.5 then is the rate at which we are pumping that water into the pool. Okay? So we're saying that we're pumping water into the pool at a rate of 1.5 feet per hour. The 2 is going to be our starting point. So that means that 2 in this case would mean that we're starting with 2 feet of water in that pool. So whenever you're looking at a y-intercept, that would be the value of y when time equals 0. So at the starting point, we have a height of 2 feet. We're pumping water into the pool at 1.5 feet per hour. All right, and that's all we have for lines. As always, send me those questions if you have them on the homework. Come see me during student hours if you need to. We do have a test coming up now because we're at the end of the unit. So please let me know if you have any questions prior to that test. Otherwise, have a great day, and I will see you next time.